Okay, let's try this again. I just did it and realized I didn't hit record, so I have to go through this again. All right, and also I kind of expanded my camera. I know I got a lot of notes last week saying you couldn't read what I was writing on the side. So we're gonna have a quick review here of truth tables and practice filling these things in. So for this first one, we're given two simple statements. It is raining is statement P, and statement Q is we go to Six Flags. So our statement in words is if it is raining, then we will not go to Six Flags. So if it is raining tells me right away that this is a conditional. So that's my arrow. It starts with if. And if it is raining, that is statement P, so that becomes my antecedent. And my consequent is we will not go to Six Flags, so that is a not Q. So when we're doing these truth tables, we should know if I have two statements, I'm going to have 4 rows. I have 2 logic symbols, an arrow and a negation, so that adds an additional 2 columns to my truth table. Okay, so I'm going to have a truth table with 4 columns, and in this case, also 4 rows. When we start with 2 statements, hopefully by now you know you're going to start with 2 true, 2 false. Second row is true, or second column is true, false every time. Okay, so then I go here, I want to do my arrow. I have the antecedent, but I do not have the right side. I don't have the consequent, so I need to build a column for that. And a negation is fairly straightforward. If this is true, the negation is false. And if the statement is false, then the negation must be true. So this is just the opposite. Anytime we're doing a negation in a truth table, it's just the opposite. All right. Then I have both sides of this arrow, so I can fill in this column. This says that if P, then not Q. So what that means is if P is true, then not Q must be true. So I'm going to look at column 1 and I'm going to look at column 3. Those are the 2 sides of this arrow. So the antecedent is true, and if I look over here at not Q, it's false. But this says that if P is true, then not Q must be true, and it isn't. So this is the outcome where that becomes false. The antecedent is true, and the consequence is false. In the second row, I think it's good. The antecedent is true, and the consequence is true. That's what this says, that if P is true, then not Q must be true, and it is. Okay. And then these last 2 tend to be the easiest, but they also mess us up a lot. Here, the antecedent is false. This statement says that if P is true, then not Q must be true. So it has to start with P being true. Since it doesn't, this statement is automatically true. It can't be false because this says if this is true, then this will be true. Since the antecedent is false, this statement is automatically true. Okay? So I don't even have to look at not Q, because this starts with if P is true, and because it isn't, then this statement must be automatically, logically true. Okay? All right, so is the final statement a tautology, a self-contradiction, or neither? We're looking at this last column. A self-contradiction has to be always true, or excuse me, a tautology is always true. Okay? A self-contradiction is always false. Let me just check, make sure you guys can see that. Maybe I'll move it over just a little bit. Okay? All right, so because we have false and truths, because we have a false and truths, this is neither. Okay, and the explanation is you have false and true. Okay, why does the above truth table have 4 rows? Again, we've already talked about that. Because we have 2 statements. Okay. Notice there's no column for not P. Well, I don't have any symbol that says not P, so I don't need it. Okay. There's a column for Q, even though the final statement contains not Q. So why did we put this in here? Because we're always going to start with the simple statements. Okay? So we're always start with simple statements, which are the original ones. Okay? All right. So hopefully that gets us started. Moving on to question 2. Fill in the truth table, determine whether it's a tautology, self-contradiction, or neither. If you've been doing your homework, you've probably already come across some of these. So what are my simple statements here? P is Hannah can solve the equation. Q is the polygon has 5 sides. And R is the polygon is a pentagon. Okay? So the simple statement we want here, the polygon is a pentagon if and only if it has 5 sides. So right away we should see that this is a biconditional because of the if and only if. Okay, so the polygon is a pentagon. That was R. So I'm going to start with R if and only if it has 5 sides. That was Q. And then I see this comma. So this is one side of something. Okay, so I put parentheses around that. And Hannah can't solve the equation. So this is and not P. All right. So that's my statement. You can see it's also here. Okay, I just wrote it a little bit bigger. All right, so what do we have here? We have 1, 2, 3 statements, 3 letters. So that's going to give me 8 rows. I then have 1, 2, 3 logic symbols. So that's going to give me a total of 6 columns. Okay? So whenever I have 3, again, it's doubles each time. So I went from 4 rows to 8 rows. So I'm going to start with 4 true and 4 falses. 2 true, 2 false, 2 true, 2 false, true, false, true, false, true, false, true, false. Okay? So that's the way we're going to start always with 8 rows. So then I have a straightforward biconditional. R implies Q. R if and only if Q. So the rule for this is they have to match. This says that if R is true, then Q must be true. But also says if Q is true, then R must be true. So these need to match. The biconditional should be fairly straightforward in a truth table. So in this first row, I have 2 trues. That's good. That's what I'm looking for. Here I have a true and a false. That's not good. They have to match. They have to either both be true or both be false. So row 3 doesn't work. Notice when I get to row 4, now they're both false. So that becomes a true statement. Row 5, they're both true. Row 6 and row 7 are both, they're true and a false, false and a true. And that becomes true. Okay? So the rule for the biconditional, they have to match. The 2 columns have to match. Then I have a negation P. Negation of P is again, hopefully straightforward. I just take the opposite of this column. Well, this column happens to be the first one. And the first one was 4 trues. So I'm going to start with 4 falses, followed by 4 falses. So I'm going to have 4 trues. Okay. And the reason we do the truth tables like this, you can't look at this as all one huge statement. This is just an and statement where I'm comparing 2 columns. This is just an and. It's column 4 and column 5. And my rule for an and says they have to both be true. So all I'm really looking for is the rows where these are both true. And here they're not, here they're not, here they're not, here they're not. I don't get one of these until the 5th row where they're both true. And as it turns out, it's also in the 8th row where they're both true. All the other ones, it doesn't really matter. I'm just looking for 2 truths because it's an and statement. So these are all false. False, 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 false. Okay? So it's just an and statement. I guess I ended up doing the whole thing for you. Okay? So this first page, you should be pretty well with. All right, next page. Looking back at that last table, is this a tautology, self-contradiction, or neither? Again, we had both, so this happens to be neither. Okay? Why does this have 8 rows? Because we had 3 statements. Let me switch to a little darker ink here. Okay? All right, for the 3 simple statements, P, Q, and R, how will you know how to fill in the trues and falses? Okay, well, again, for statement P, what did we do? We started with 4 true and went 4 false. For Q, we went 2 true, 2 false, 2 true, 2 false. And then for R, what did we do? We did true, false, true, false, true, false, true, false. Every time they're going to set them up like that. Okay? So what if we had another statement? What if we had 4 simple statements? Well, what's going on? When we had 2 statements, we had 4 rows. When we have 3 statements, we had 8 rows. So 4 statements is going to lead to 16 rows. It doubles every time. Okay? But again, you won't see any of that in this class. The most we're going to have is 3 statements. Okay? All right. So let me do a little bit more here. This one I'm going to set up and let you guys do the truth table on your own. So it is Monday is statement P. I have a doctor's appointment in the afternoon is Q. And R is I attend class in the afternoon. So my statement is I attend class in the afternoon, comma, and if it is Monday. So this first one is I attend class in the afternoon. That is R. Okay. And that's separated. So that comma separates this conditional statement. If it is Monday, so if it is Monday, then I have a doctor's appointment in the afternoon. Okay, so this conditional statement is kind of by itself. That's why I put the parentheses around that. I didn't want to have R and P because this R separates it. Okay, so what do we have? We have 3 symbols, 3 statements. So P, Q, and R, I'm going to have 8 rows. Okay. If I were doing this, the first thing I would do is the simple conditional P implies Q because that's in the parentheses. Okay. And then my last row is simply going to be an and statement. It's going to be R and P and Q. And you should have both of these columns. Here's column R. Here's column P implies Q. Okay. So pretty straightforward once you get to that. Okay. All right. If you've been doing your homework, you know what? Let me go ahead and fill this thing in for you. True, 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 true. I'm not going to do this truth table, but that's how P would start. Q would be 2 trues and 2 falses. 2 trues and 2 falses. True, false, true, false, true, false, true, false on R. Okay? So, if it is Monday, you have a doctor's appointment and you don't attend class in the afternoon, that's one row of this truth table. So if it is Monday, so P is true, so it's got to be one of these. You have a doctor's appointment in the morning, okay, so it's got to be one of these now because Q is true. That was, and you don't attend class in the afternoon, so R is false. So this question A is pointing me towards one row in my truth table. It's pointing me towards this. So the answer to A is going to be whatever you come up with for this one. Okay. So sometimes they're going to ask you about a specific row in a truth table. In this case, they're asking me about this, where it is Monday, I have a doctor's appointment, but I don't attend class in the afternoon. Okay. In this, I kind of already talked about why is R and P not appropriate. It's because of this little comma right here. I'm not going to do R and P implies Q. It's R and P implies Q. So that comma separates those things. All right? All right. So this last one, you can see I've already kind of started this. Okay? For this problem, we need to construct a truth table entirely on your own based on a sentence. Okay? So we're kind of putting everything together now. The statement is, I shower quickly and I drive on the highway, comma, or I do not get to school on time. Okay? So the first step of this is to assign simple statements. P is I shower quickly, Q is I drive on the highway, and R is I get to school on time. Okay? So this statement is I shower quickly and I drive on the highway becomes this. P and Q. Okay, and then I see that comma, so this is one side. So that's why I put that in parentheses. Okay, there's no if here. There's no if and only if, so there's no arrows. Okay, then I see an or, so I put in an or I do not get to school on time. Okay, so you should see you're going to have a truth table, and I'm going to leave this one to you. You have three simple statements, P, Q, and R, so you're going to have 8 rows. And you have 3 logic symbols, so you should have 3 plus 3 columns. You should have 6 columns in this truth table. Okay? So I'm going to do this video in 2 parts because the next one talks about arguments. So part 1 was just truth tables, and then we're going to move on to arguments.